Okay, continuing with the problem. We already know what's going to be the force applied at C. We already know we're looking for the moment at A. We already know what are going to be our vectors. Now, the one vector that goes from A to C is the distant vectors. However, the vector that goes from C to D, it's a distance vector, but we will not use it straight like that. For that vector, we require the direction. And that direction is given by lambda. Lambda CD. Remember that lambda actually going to be calculated as the component of the vector D CD in I over the module of the vector DCD plus the component of the vector DCD in Y over the module of my vector DCD plus the component of the vectors DCD in C over the module of my vector DCD. Hence, we need to obtain what is the value of the module. So our module is going to be calculated as module of the vector D CD equal to square root of each component of my DCD vector. That means 0.3 square plus 0.24 square plus 0.32 square. The result for that will give us the model, and knowing the model we can calculate lambda. The model will then be 0.3 square plus 0.24 square plus 0.32 square, square root of that, 0.5. Hence, lambda can be calculated as the component of CD in X minus 0.3 over 0.5. We can just leave it like that, no need to make the calculation. That's going to be more exact. This in I plus the component in Y, 0.24 over 0.5 plus the component in K, which is going to be, this is going to be negative 0.32 over 0.5 in K. That's going to be our direction. Now, why we need that? We need the vector or force. However, the vector force is going to be composed by one magnitude, which we already know, and we require the lambda, which now we know. So, to create the force vector that we're going to use, we will multiply the 200 newtons times over lambda, lambda CD. That's going to deliver that the force vector, remember vector, it's going to be 200 times minus 0.3 over 0.5 minus 120 in I. Then plus 200 times 0.24 over 0.5, 96 in J, this I, minus And that minus is going to be 0.32 times 200 over 0.5 minus 128 in K. That's going to be our force vector divided in the three components. These are going to be used next.